to determine the pH of a for buffer solution, we need to know the pH of the buffer solution also. So how do we determine the pH? That can be done using buffer equation or Henderson-Hesselbalch equation. Both of these names can be used for this equation. Now let's see how we derive this equation. So first of all, consider an example of a weak acid and salt. So I have taken a journal weak acid Ha and its salt Ma. Now we know that salt dissociates completely into its ions. So I have written 100% here. So Ma is 100% dissociating into its ions, that is Ma plus and A negative. Now Ha, being a weak acid, dissociates to a very smaller extent, but here also due to the common ion effect, its dissociation is further diminished. So here common ion effect is coming into play. Common ion effect. Alright. So it is coming into play and further diminishing the dissociation of your weak acid. So if you apply the equilibrium law here, what will be the Ka? Acid dissociation constant will be equal to concentration of H positive into concentration of A negative divided by concentration of Ha. Alright. And since the dissociation of Ha is to a very small extent, so we can say that concentration of Ha is nothing but the initial concentration of acid you added. So during when the equilibrium is established, the amount of acid will be approximately equal to the amount of acid you added while preparing that buffer. So Ha, concentration of Ha can be written as initial concentration of the acid you added. Similarly, since this salt Ma is 100% getting dissociated into N positive and A negative, and the contribution of acid toward the A negative is negligible, so we can say that the concentration of A negative ion is equal to that of the salt, that of the initial concentration of the salt. So A negative concentration can be equal to concentration of salt. Similarly, concentration of Ha can be written equal to the concentration of acid. Now starting from our first equation, that is acid dissociation constant, if we rearrange this equation, then it can be written as H positive is equal to Ka into concentration of Ha divided by A negative, and these two concentration terms can be exchanged by concentration of salt and concentration of acid. So that's what we have done in our equation second. Concentration of H positive is equal to Ka, that is acid dissociation constant, into concentration of acid divided by concentration of salt. Now if you take negative logarithm throughout the equation second, so you will get minus log H positive is equal to minus log of Ka minus log of ratio of concentration of acid to the salt. Alright, this minus log H positive is nothing but pH, and minus log Ka is nothing but pKa, and the remaining term is as it is. This fourth equation is Henderson-Hesselbalch equation for acidic buffer. So this equation is valid only for the acidic buffers. Similarly, if you have a basic buffer solution, so you will get a equation for concentration of hydroxide ion like this. Concentration of hydroxide ion is equal to Kb into concentration of base divided by salt. And again, taking the negative logarithm, you will get a relation as POH equal to PKB minus log of ratio of concentration of base and salt. So So these two equations are used to determine the pH of acidic buffer solution and basic buffer solutions respectively. So let's say if you have to prepare a pH of some um, 4.7, so what you will do, you will take a acid which will have a pKa value around that pH, and then you using this equation you will determine the ratio of concentration of acid and salt required, and then you will mix those together to get your desired pH.